zigzagging a list in Java. This is going to be interesting. All right, so as the introduction in the previous video, you're given a list and you're like, in this example, numbers 1 to 7, and then you're told to zigzag them. In this case, from low to high to low to high. So you are expected to get a list of 1, 3, 2, 5, 4, 7, 6, low, high, low, high, low, high. And then can you flip it where you start with a high, low, high, low, high, low. As I explained in the previous strategy, I'm going to keep track of the flag, like a true or false value with the flag. If I start with a true one, that means I'm starting with the low one. And then if I start with a false one, that means I'm starting with a high one. And if the flag is true, I expect the current to be greater than the previous. Else, if the flag is false, the current is expected to be less than the previous. And the current one is the next one, and the previous one is the previous element in the list. My implementation, I implement this using an array because that's easier, and then I move on to a linked list because so many things are happening in a linked list and it's harder to see that. But once you know how to implement it using an array, it's easier to do it in a linked list. So now we're going to do this in Java. So let me open my integrated terminal. Let me see. Yeah, there's nothing there. So I'm now going to make, I'll just call it zigzag. And Java is an object-oriented language. So I'll have to create a class called zigzag. Okay, that. All right. So I'll create a public class called zigzag. And I won't instantiate anything, so I just use the class itself for all these methods I'm going to create. So I'll be using static methods. But if you want to instantiate an object, you can not use static method. But in this case, I'll just use everything static. Public static void main, which receives a string of arguments. And this is what I'm going to be playing with, like the arrays. Actually, let me even instantiate an array. And we're going to put then counting numbers. And instead of printing them here using a for loop, I'll just move like all the print stuff into a method I'm going to call print. In order to display something, you have to loop through the array and also use system.out.println, but I'll just create this method called print, which I'm going to now create. And since I'm not instantiating anything, I'll just use static method. I'll call it print, and it's going to receive an array of elements. Of integers in this case. And I'll loop through the array. Wow. The length is less than the array length. I'm gonna do system out, and I'll display the array element. So seems like this. There are some over there. Static void print. Why is it? Okay, let's compile. Let's see what happens. Oh, okay, actually it's correct. It's printing now, but you see the way these numbers are coming out, one on top of the other. So I'm gonna remove that here, and then I'm gonna close it using that, and then I'm gonna open opening brackets there. But obviously I don't want that. And then I'm gonna check if the I is less than the array dot length -1. That means it's within the array. I'm gonna put a comma on the space. And if I save it, compile it, and print that, okay, that prints perfectly there. All right, so we have a utility function which prints our array. Now I'm gonna zigzag. I'll call the function zigzag, and I'm gonna pass in my array, and then I'm gonna print before zigzag, then this is going to be after zigzag. All right, now we need to create this method called, it's also going to be a public static method which returns nothing. It's just going to zigzag the array. It's going to receive an array, and if we go to the conditions here, we did say that we're going to start with a flag of true, and then we're going to check the current one with the previous one, and then if it's like this, let me set those on there. So we're going to start with a true flag, and then if the flag is true, we expect that the current element we're on is going to be greater than the previous element. Else, if flag is false, we expect that the current element we are on is going to be less than the previous element. Otherwise, we're going to swap. All right, so we're going to initialize the flag, a variable flag, which we're going to give a value of true. and then we're going to look through the array. And since we're always checking the current one with the previous one, we're going to start at 1, and as long as we're within the array length or the bounds of the array, we're good. And then we'll start checking those. So we're going to check if the flag is true and the current element we're on. Here, the statement is if it's greater than, but in order to swap, it has to be the opposite of that. So we're going to say if it's the opposite of what we expect, we're going to swap. So we're going to swap, passing in the L array, and the left or the previous index is going to be I minus 1, and the current index is I. So this is going to be on the left side of the array, and that's going to be on the right side of the array. And then we're going to do the same thing, but this time for the false value. If else the flag is false, the statement here, we expect the current one to be less than, so we have to do the opposite to swap. And at the end of it, of the if checks, we're going to flip the flag. All right, now we have to implement this swap method here. So I'll just put it right underneath the print function here. This is going to be a static method which will return nothing, but it's going to receive an array of ints, and it's going to have the left index of the previous index, which is going to be on the left, and the right index. Both are going to be integers. I'm going to store the left element in the array. I'll store it in a temp variable, and then I'm going to replace that left spot with the value on the right spot, and then I'll now bring back the left spot and put it on in the right spot. So I'm swapping, and that right left value we stored it in the temp. All right, so if everything is good, if we compare this, it works. So 1, 2, 3, 4, 5, and then 1, 3, 2, 5. You see that? Now, what if we wanted to start with a high number? We're going to just change that to false. And if we compile it, it goes with 2, 1, 4, 3, 6. So that's also working. So I'm going to put that back to true. All right, now we've answered this question with an array. What if we wanted to actually now use an actual list? How are we going to do this? Java has got classes for that. So we've dealt with arrays. Now we're going to deal with linked lists. All right. So what I'm going to do is I'm going to instantiate a linked list of integers. Uh, if you notice here, I'm using int here as like primitive, but here I'm using integer, which is like an object. Now just call it class, and I'll instantiate this linked list. I could have put in integers here, but because I've put it here, I don't need to do that. All right, now I'm gonna populate this linked list with numbers, but instead of saying add 1, add 2, I'm just gonna like use a for loop and count 1 up to 10 or up to 9. Then each time I'm just gonna be adding to the list. All right, and I'll do something similar like this. So I'm gonna print, but this time we're printing a list. All right, if we run this is gonna give us an array, an error because we don't have the print method. Yeah, this print is receiving an array, but this list we're passing in is a linked list. So we have to just like overload a method called print with a linked list in there. And the easiest way is, so let me put some comments. An array, print an array, swaps, array elements. I'm gonna put it underneath here. So print linked list. All right, and I'm just gonna pass it in a linked list. By the way, that linked list should have been imported there. Let's see. It's import. What I've noticed is if I do an import like that and then just like delete it, it usually imports itself. Let's see. Oh, okay, it doesn't want to import. And that's going to be in the Java utils. All right, okay, so in order to use it, we're going to link to the list. All right, link list. Okay, there we go. All right, and we're going to use this instead of the square brackets, we're going to start with a head, which is going to have a pointer. And at the end here, we're going to have a star, which is going to end with the now. Obviously, we don't need this. All right, now for a linked list, I'm going to use what is called a list iterator instead of using a for loop. So I'll just delete this. And I'll instantiate a list iterator. And I'll call it an iterator for it. And I'll say list iterator. And I'll start at the beginning. Do we have the list iterator? Yeah, come on. Yeah, okay, it's imported there. That's great. All right, and then what I'm going to do is I'll just use a while loop. Actually, not a loop. Traverse through the list using the method called as next. If it has next, I'll just print it out. And it'll be printing out next. And then I'm going to append that with that kind of. All right, okay, so I'm going to comment this zigzag so that I can just test out the print methods for the UTL. All right, obviously that print I don't want it to print a new line all the time. All right, let's compile that again. So okay, so the printing is working. So now we just have to implement the zigzag method. All right, as you can tell, this zigzag method has an error. So we're gonna overload this zigzag method. This time, passing in a linked list. So I'll put it right underneath the other zigzag method. It's gonna be public. By the way, this swap method, I'll just make it private because it's being used by this class and nothing else. So public static void zig come on zigzag. I'm gonna pass in a linked list of integers, and I'll just pass in a list. I'm gonna make a small change. Instead of this zigzag, I'm gonna switch it up to a camel cast zigzag. That means I'm gonna change that zigzag to camel cast. All right, so camel cast zigzag. All right. All right, now I'm gonna check I can use an iterator for this, but I'm gonna use another method, just like iterating it using a while loop and the index, because I can use the get index for that list. So I'm gonna use that way of doing it. But because I'm checking the current one, which is like one spot, and going back the previous one, I'm gonna first check if there is actually something in the first element. So I'll do, and also just to try out other methods of this linked list. So I'm gonna pick at the first element, and as long as the first element is not null, then I'm gonna start traversing this list. And I'm gonna use the rules that we talked about. So we'll start with a true flag. And then if the flag is true, expect, I'm gonna use a method called get on the list. So expect the current index we're checking to be greater than the previous index, which is kind of like current should be greater than previous, kind of like that. And I'm just going to copy that, and I'm going to reverse. I'm going to say if flag is, and I'm going to use else here. If flag is false, expect this to be less than the previous. So yeah. Otherwise, we're just going to swap. All right, now we can start with a variable called flag, which we said we're going to make true. And I'm going to use an index. I'm going to use a while loop for this. But instead of starting at 0, because we're checking that the first, we're checking that the first item is not now. So now we can go to the next one, which is 1. And while the item we're looking at, or the index, is less than the size, I'm going to use the method of size, and that's going to keep us within. And so just to prevent infinite loops, obviously I'll increase, and then at the end of whatever I'm going to do on top, I'm going to flip the flag. So I might as well put it there. All right, now I'm going to start. Here we're going to check the current and the previous one, but instead of like using this listed gate, I'm just going to store those in a variable so that you can actually see them properly. So the current one and the previous one, my computer's freezing. But once I do have those two, then I can just start comparing. So if the flag is true and the current one, you were saying is greater than, so we're going to do the opposite. And then we're going to swap. And then when we swap, we're going to pass in the list and then the previous index and the current index. So we're going to do something similar, but for the false value. So if the flag is false, here we're saying it's less than, so in order to swap, it has to be greater than. Okay, so we need to create this swap method. The other swap is for an array, so we need to implement something like this, but this time for a list. I'll just copy that. My computer is freezing now. It's going to be swapping list item. Obviously, this is going to be a linked list of integers. Right. Right, so we're going to grab what's on the left. We're going to use the get method. And we're going to now put it using the set method. We're going to replace what's on the left with what's on the right. Right. And what's on the right, we're going to replace with what's on the left using the temp. So yeah, just to go through this again. So we're grabbing what's on the left, we're placing it in a temp var. Then we're grabbing what's on the right and we're replacing what's on the left with it. And then we're replacing what was on the left with what was on the right with what was on the left, which is stored in the temp. Why is it? Linked list, integer list. List, integer. Yeah. I don't know why that's complaining. Private static void swap linked list. I think my computer is just slow. Oh, there we go. Okay. All right. Now, moment of truth. All right. So you see, 1, 3, 2, 5, 4. So it's working. And if we went here and then this is for the linked list here. If we change that to false and compile again, yeah, it flips. So that's perfectly working. All right, I've done the same thing in C++, JavaScript, and Python. So, and all the code is going to be on GitHub, so you can check it out on there. Thanks.